Alright, class. We're going to finish our lecture on sections today. Which is going to be starting back on page 182. Page 182. I went ahead and decided, okay. I mean, I can leave it up to y'all, but I'm going to go ahead and finish out the sectioning lecture today. And then we can either continue on through the dimensioning lecture or save the dimensioning lecture for next week. So which one would y'all rather? Huh? How much do y'all listen to me today? Do you want to go ahead and do the entire lecture today? Speak now, forever hold your peace. Alright. Let's get started on page 182. We've talked about two different styles of sectioning so far. What two styles were they? Full section, which was what? The cutting plane did what? Went all the way through. And the half section, the cutting plane did what? It basically stopped at the halfway point and it jotted across, right? Thinking of a half section, cutting it into a quarter is a good thing, but just remember, you know, a lot of people, they start getting that quarter in their mind, and when they see it go halfway down the page, they don't think it's a half anymore because they're thinking quarter. Remember, a half section, a full section depends on what the cutting plane line is doing. The cutting plane line goes all the way through, it's full. If it goes halfway, it's half. Alright, now what we're going to talk about today, a few of the ones we're going to talk about today, doesn't even involve cutting plane lines. Okay? What they can involve are short break lines. You've heard that before, which when we were talking about the alphabet lines in like the second or third week, one of the alphabet lines were the short break lines. Alright, let's say for example, let's say you got some kind of image. It's got some kind of hole going through this thing, that some shaft or something's going to go through. And let's say that you have, let's say the shaft's coming through like this right here. But coming down to this shaft is some type of hole. Huh? Oh yeah, it'd be nice if I turned the video on. That'd help me. Alright, sorry about that. Alright, you see I drew this image. This squiggly line right here is the short break line. Okay? So basically what I've shown is, look, all I'm doing is this, at this point right here, I'm just taking the top part of the object off, or that piece of the object off, so I can show you just in this key piece of information right here. And what I was trying to show was this right here. Generally, what kind of What is that generally for? Huh? Some kind of pin, or if it had a nipple on it, or don't even have to have a nipple, but that could actually be even like a fluid. Yes, exactly. Where you put your grease in, or something to lube up, oil, anything like that, or it can be some type of pin that's coming down to lock this in. So instead of it'd be hard to cut a section, like a full section or a half section, to show that, which is what I'm trying to show you. So to get around that, when we need to just show a part just like inside of an object, we use the short break line. Okay? Because if you look on page 182, down toward the bottom, right above that figure 6.21, they're showing you the same kind of example. Okay? And if you look at the very bottom, they did a little short break line just to show that the threads, how far the threads go down through this object. So that's kind of what this is considered a broken out section. Broken out. Which means you're just basically breaking that little bitty piece of part of off just to show this one key piece of information. What do you notice? How do they draw it though? You basically draw like a front view of it, or a top view, or whatever it is. So you just draw a multi-view of it, an orthographic view, and then you just do the little broken out section on top of that view. You don't draw a separate section. Okay? So that's what we consider a broken out section. The next two we're going to go over, people get confused. Okay? A lot of people get these confused. We're going to go over revolved, and we're going to go over remove. Revolved and remove. Alright, if you look on page 183, you can show the shape of the cross section of a bar, arm, spoke, or other elongated object in the longitudinal view by using a revolved section. To create a revolved section, first imagine a cutting plane perpendicular to the center line or axis of the object as shown in figure 6.248. Next, revolve the plane 90 degrees about a center line at right angles to the axis. Okay. After saying all that, all you are doing is, let's say you were cutting down through something. Okay? Do you know what it means when you say cross-sectional? A cross-sectional really don't have anything to really show. Yes, this right here. Alright, we're going to take example. I have a truss. This is a truss. Okay? This is a floor truss or whatever. You see what the shape looks like from the end of it, right? What shape is it? It's an eye. Okay? If you were looking at it from the side, would you know that? Okay, you wouldn't. So, let's draw that. I'm going to stick this up here. So let me draw what this would look like from the side. Okay? Alright, so that's what it looks like from the side. Now, instead of cutting a whole different section and putting it out somewhere and taking up more space, if you wanted to show the longitude, the cross section of this, what the cross section is you want to show what the shape of it actually is. Okay? Like if I was to cut through this thing, basically it's like taking a full section, cutting through it, and showing what the end of it looks like. Okay? So if I wanted to show the cross section, instead of putting it out over here, cutting the section and all that, all I actually have to do is come in here, erase part of my object out, I think I just stepped on the surge protector down here and turned it off. So give me a second, let me get my computer back up now. Alright, try this again. Alright, so basically then what I would do is remove just a portion of the middle of the object, come in, and draw exactly what this image would really look like if I was looking at it from the end. Okay? You can either leave it where it's kind of cut like this, or you can have it where it actually and this is mostly the way we kind of do it. You would do it like that. Then you would put your section lines, of course, just like you did on this last drawing, where you had to put your 45-degree lines in there. You would do that same thing just in this portion right here. Okay? So that would be a revolved section. All you did basically was take your object and revolve it. You turned it 90 degrees. Okay? So that would be a revolved section. Now, the next one we talk about would be removed. Okay, the next one is going to be a removed section. And that's over on the next page on 184. The difference in revolve and remove is how we have this section right here. Okay, how we have this section right here. If we didn't have it right here, on top of the object, and we drew it, let's just say over here, instead, and it wasn't lined up with this object whatsoever, then we basically just said, drew a line. I'm trying to say, it's doing the same thing you did on revolved. It's taking a cross section of the object, except you do not put it on top of the current drawing. You actually put it over in a different area, and most of the time a removed section is not to the right scale, because a lot of times you're trying to blow it up. It's at a different scale than your other drawing, so you try to blow it up so you can see. It's not. It may not be exactly lined up with the object. It's just kind of sitting out there. You're calling it out. Hey, this is section blah blah. It's an enlargement or whatever. And you can see that at the bottom of page 185. Look at the bottom of page 185. You see how they took and did cross sectionals at the very bottom, and they just put them out beside the object? It's not on top of it. That's basically the difference between removed and revolved. Revolved had actually been sitting on top of the object. Removed, it's away from the object. And in all honesty, most of the objects, or most of these sections that we actually draw in the field are removed sections. Because removed sections are not in direct alignment with the object. You saw on this object you just did, or this drawing you just completed, or going to complete today, it was a full section. But what did we do with that full section? Was it not directly aligned with our object? We could project straight down, couldn't we? Well, you'll see when you get out in the field, when you draw sections, most of the time your section is on a completely different sheet than your object. So that's why really in the field, this is the thing we use the most. Now, a removed section is not just showing a cross section. A removed section can be an enlargement. For example, look on page 184 at the very top left. You see where it says section AA 4 times the size? That section AA is actually an enlargement. It's basically an enlarged, broken out section is basically what it is. But since it's removed, see, and that's what you'll understand real quick about a removed section. It's actually a couple different sections put together. It can be a full section, helping make it a removed section. Because remember, the only thing that makes it a removed section is if it's not in line with the object. Okay? You can look at the top of page 185, or look at the bottom of page 184, then we'll go to 185. You see they got all these sections, AA, BB, CC, DDE, blah, blah, blah. Notice none of them are in direct alignment with the object. How do we know they're not in direct alignment? Do you not remember when we said that the cutting plane line, the arrowheads, whichever way they're pointing, your object's supposed to go the opposite way? All those arrowheads are pointing to the left, so our object should actually be on the right-hand side of that object. Well, where are they located? They're in the bottom, so they're not in direct alignment with the object, which makes this a removed section. But notice about it. Notice about the cutting plane lines for them. They're a full section, right? It's a full section cutting plane line. You notice that? Like AA up there in the middle of the object, AA, BB, CC, the cutting plane lines, they go fully through the object. But this is not considered a full section because the sections that were drawn are not in direct alignment with the object. So that's why it makes this a removed section. So that's why you have to be very careful with these when you're paying or when you're looking at them, especially for the final exam. Okay? Because you may see a full section cutting plane line there, but if it's not in direct alignment with it, then it's not a full section. It's a remove. And then you can see on top of page 185, if you were working in a residential architectural field, that is the type of sections that we actually cut. Okay, we cut cross sections of a house like that. They're not in direct alignment with our floor plan. They're actually on a whole different sheet of paper, so they are a removed section. Everybody good with that? All right, page 186, the offset section. All right, let's say we have three objects on this. I got drawn up here on the board. Okay. Let's say this back here, this little rectangle right here, is a wall that sticks up. Okay. We're going to say it's a wall sticking up. We're going to say this piece here are both going all the way through this object. So let's say, all right, I'm going to show you a side view of this. This one right here goes all the way through. This one right here goes all the way through. We'll show two different center lines to show that, hey, there's two holes going through this. Then this one right here, I'm going to say, actually, all right, so you can see kind of what's going on in this object. Two of these holes actually are on the thinner part of the object. This one's more of a tower. It goes down. This actually would be more like that. Okay, so you got a tower. Actually, no. So, an offset section, what it is basically a full section. Okay? Except your cutting plane line does not go in a straight single path. It's going to do some jotting to catch different things that you want to catch. So let's say I wanted to do this one. So I'm going to come down with my cutting plane line. I'm not going to put the fan all the way there. Alright, so there's my arrowhead. As you can see, it is not a straight line path, is it? It does all kind of jotting and coming back and doing all that. But when you do this, and you go to draw a section, an offset section still has to be in line with the object. As you can see, the arrow has to point to the left, so I drew my object on the right. Correct? Okay. Wait a little bit. When you cut an offset section, what you got to be careful about is, even though you're cutting through that object in a certain place, you still have to show anything that's sticking up. Remember that line of sight we talked about? Like even if you're cutting through a hole in a section, that we do not leave the top as a blank hole because it looks like separate pieces. We actually have to connect it. You remember what I'm talking about? For instance, we had a hole like this. When you draw the section, you have to have a connecting piece right here because of the line of sight, because you can actually see that edge, right? This is the same way that happens here. Just because I'm cutting through here and I'm not cutting through here doesn't mean I don't have to show this. Remember, this line right here is this point right here, correct? This is wall. So I would actually have to know, okay, I'm cutting through this section right here, which means I am cutting through all of this right here. So I would have to know how tall is that. And I would have to put me, of course, this right here, this edge right here would be what? Be the top of this wall, wouldn't it? Just think of it like this. This section I'm cutting through right here is basically looking at this from that direction, correct? So I'm going to see this wall. I need to know the height of this wall, and I put it, like I said, this piece right here is the top. I have to put this piece right here across there. Alright? Now, I have to put where my holes are cut. Okay, so I can come over here and put my hole there. I can come over here and put this hole there. And this one right here is not only a hole, but it is also what? You have to show the tower. You're cutting through it, right? Now watch how this will work. That's basically that object right there, but when you put section lines in there, it kind of helps you understand what is going on. So I'm going to go ahead and put my section lines in here. That makes it a little easier to recognize now how this object is laid out. These section lines shows you that all of this is solid. This has got a tower coming up in the middle of this object because you see this part of it is solid. It's got a hole going down through the middle of it. And then it shows you got 3 holes, and then when you see this right here, and you see all of this is solid, that tells me that this must be some wall in the background because I did not cut through the wall. Okay? So by looking at these two right here, and then seeing that, you you get a very good representation of exactly what is going on in these locations. They show you another example of that down at the very bottom of 186. You see it has the object there. They cut 3 different offset sections. They put all 3 of them to the right because the arrowheads are pointing to the left. And you really need to study that. You really need to look at it because you need to see, because guess what your homework assignment is going to be? You got to do 3 different offset sections off of one object. So by looking at the bottom of this page, it will actually show you exactly how you're supposed to show things. You got to show the background edges and all that kind of stuff. All right, does everybody understand that, or do I need to go a little further with it? You have to show everything that you cut through. Okay, everything that you cut through has to be shown. But then you also have to show anything that's in the background that is above what you're cutting. Just like I did right here. This line in the background is above. It's above all of this right here, isn't it? You see, it's higher than this, it's higher than this. So you actually have to show the outline of it in the background. Alright? So you might want to just make a note and look at bottom of page 186. That'll help you with your homework assignment. I think we talked about this, ribs. Ribs in section. You know what a rib is. Best way to show you what a rib is, if I took this right here, and I turn around and put a piece of metal, now let's say I went the full length of this, right against the edge of it, to give it support from buckling one way or the other. That is considered a rib. This would be the rib, okay? Or a spoke, like on a tire or something. When we draw sections, if you cut through a rib in a section, you do not show it as a solid object. What I mean by that is if you look at the top of page 187, you see at A, they cut through the rib right there, right in the middle of that object. But over there at B, they did not show hatch lines where the web was, where the rib was. Okay? The reason being is if you look at B and C on the top of page 187, what does C give you? It kind of gives you a poor portrayal of what is actually going on with this object, doesn't it? Because it looks like it's just one massively solid object when it's not. So B, they show you wherever the rib is or the web, you do not hatch that part. Because what this basically shows then is it's actually showing what the thickness of the object, because you can see the little thin walls now, and then it shows that web is right there on the edge. Okay? So that's why we do not actually hatch or section a web or a rib. All right, we got a couple more. Let's move on to a line, an aligned section. bottom of page 187 shows a very good representation of what an aligned section is. You see the cutting plane line goes down and it jots off at an angle. But it still has two arrowheads on this cutting plane line. It still has two arrowheads. So what they're doing, let's see if I can show it on here. What they do, okay, is to do an aligned section, you would basically take your, how would you say it, you would basically take your compass and you would stick the needle right here in the middle, wow, 3 or 4 more. Right here in the middle, you would take your compass and you would put your lead right out here on the edge of this object. And what you would do is you would basically come and draw you a dotted line as your compass stays in the middle there until it hits your center line. And you would do that with every edge that your cutting plane line is hitting. Because what you do then is once you figure out where it hits your center line, you draw a line straight across, and that shows you where that should be located on your section. And that's exactly what they're doing at the bottom of page 187. So if you notice the section is lined up with the object, well, what do you notice about it? In your book at the bottom of page 187, the section is actually longer than the object, is it not? But in actuality, you're drawing it basically the same length almost as the cutting plane line. Because what do we know about an angle line compared to looking at the angle? If you're looking at an angled line and you're not actually seeing, you can't measure the degree of the angle, then you're seeing what? Foreshortened area? So if you drew this just like projecting everything without doing the radiuses there, you would have a bunch of foreshortened objects. You wouldn't actually have what the actual length of it is. So the line that helps you, when you got something like that that jogs off at an angle, it helps you get the true length drawn out in the section. Look over page 189. They're drawing partial views. I'll just let you look at them. We don't cover them a whole lot. Because the only other thing I want to actually go over with you is page 190. How do you show pipe when you cut a section? Okay, how do you show a pipe that is cut in section? Let's say I have a piece of pipe here. And I'm going to break this piece of pipe into sections. Or, let's just do it like this. I'm going to draw up here on the board. That's a piece of pipe. Here's the end of the pipe. That's one end of the pipe. And I'm breaking this in because I don't want to show the full length of the pipe. So to show that you have sectioned that or that you have broken it out, what you have to do is at the end where you're breaking it, you have to come in draw a couple of arcs. And then you come in and you erase out the straight line. And then you hatch the part that has the double arcs. Okay? So that, if I actually drew another one on the right-hand side, did the opposite way, it would look like it actually would fit together. That's basically how you show a pipe when you're not drawing the full length of it. The end that's got the straight line is the actual end of the pipe. The end that's not drawn all the way out is your broken end. So that would be how you draw a broken end of a pipe. You can see in the middle of page 190, on figure 6.43, they show you this. They show you how you would do a pipe if you were breaking it right in the middle, just like I just stated. However, I drew it the first time on the other piece of pipe, I would have to turn it and do it the opposite way. Now, how would you show the end of a pipe? If you were looking at the end of a pipe, bad pipe. All right, forgive me, I'll probably have to draw this a few times because I always struggle. What does that look like? Yin-yang. Bad representation, but it's a yin-yang. And what you would do was hatch one side of the yin-yang. That would be showing the representation of the end of a pipe. You just draw a yin-yang in the middle, hatch one side, and bam, you're saying this is the end of a pipe. Huh? Yeah. Okay? We do this in anything. Solid piece of metal, hollow piece of metal, anything. You just draw the yin-yang, basically show this is the representation of the end of a pipe, looking directly at the middle of the pipe. Okay? So that's how you would actually represent that. Alright, so that's the end of the section. So we have full sections, which the cutting plane line goes all the way through. The section is actually in line, proportionate with the object. You have a half section, which goes halfway through and jots off to the side. It is in line with the object and proportionate. Then you have broken out, which is basically just a squiggly, short break line, just to show right there what the inside of the object is. You don't draw a whole separate section. Then you have removed or revolved, which you draw in the cross section of an object on top of the object. You have removed, which you're cutting a section. It can be a enlargement, it can be a half section, it can be a full section, but the object or the section that you draw is not in line and not in proportion with the object. So you can see, you need to know all these for your final exam. All right. That was about an hour's worth. Go up to here in another hour's worth of lecture. You're probably going to wind up coming next Monday anyway, working on this assignment. All right. So, yeah. When they say, Mr. Ladner, what do we got to do? All you people, so go find one of them. All right. Let's just film next Monday, okay? That way you can go ahead and get started on this. Because this little assignment is going to take you quite a little while. That's not going to be as easy as the one you just had. So let's go ahead and look at the assignment, and we'll lecture on dimensioning next week. Go to page 200. Exercise 6.21. You see there is a top view, and then there is a front view on that one object. It's the adjuster base. The very top left of the object. Okay. So you have a top view and a front view. Then you see they have three different section cuts. They have AA, BB, CC. All right. You are going to have to draw the top view and then the three section views. You do not have to draw the front view of it. All you have to draw is the top view, put your three cutting plane lines on there, and then draw the section views. Okay? This will all go in your 8.5 by 11 sheet of paper.
It will fit.
It will fit. You can turn this drawing anytime in between now and April 29th. And you got basically 2 weeks to complete it. Okay? So in between now and the end of the day on April 29th.
You just have to go in a row like that?
Yes. All set views are aligned with the object and are proportionate. So it's basically just like the one you just did, except now you got three of them. That's why I told you on that example back in the book, you might want to study that example. It will help you out on this drawing. It helps you show exactly what's going on. Now you will have to look at the front and the top view to kind of be able to draw your sections. Because the front view there actually shows you where all the walls are, shows you the height of the walls, it shows you all that information. So like I said, all you have to draw is the top view and the three section views. If I wanted to be mean, I'd make you draw the front view too, but I don't want to be mean.
So then when we do our math with about 4.
1, 2, I think it's 5. Go back to the bottom of page 186. There should be 5. Yours is based on the layout kind of like this. I'm going to tell you, yours is going to lay out exactly like this one at the bottom of page 186. So there's 5 gaps that you've got to figure in. So there's 5 spaces. So to do your calculations for your centering, you have to divide by 5. Huh? No, just 1. Because up and down, you'll just have 2 spaces. From left to right, you're going to have 5. But what you see at the bottom of 186 is exactly what I want to see when you turn yours in, including the title block. You see how they put section A-A underneath their section? That's what I want to see. I want to see that. What text height should you use on those callouts? 1/4 inch. So you have to draw a 1/4 inch guidelines where you see section A-A and put them, and even at the end of your cutting plane line, when you see AA, BB, CC, you'll actually have to put that in a 1/4 inch too, that letter. You do not have to dimension this. All you do is strictly draw like you saw on 186. Now, it's not the exact same object, but it's very similar. Okay? Not the exact, but it's very similar. That's kind of why I do this. This is your first time to draw one. You really have something to go by. So we'll leave dimensioning for next week, because this is your last assignment. And next week we'll lecture on dimensioning, and all that lecture is going to be good for is to finish your final exam. So there's going to be dimensioning stuff on your final exam. Your final exam opens on your computer in the next 2 minutes. It is the take-home final exam. So it opens in the next 2 minutes at 10 o'clock on the dot. It opens up. You print it out. You can start right now, this week, weekend, start answering it. Remember, it is due by the end of day on April the 29th, which is the Monday. It has to be turned in before I leave here on April 29th. And I think I'll be here probably till about 7:30 that night. Okay? So April 29th, at any time. You can turn it in any time between now and then.
On your,
But remember, final exam has to be put in my hand. You have to sign showing that you turned it in. I will have a sign-in sheet for you to do that. I'm glad it's on these recordings that I'm saying that, because then if I have any student that wants to fight because with the turn in because I gave them a 0 and they got an F in the class, and I have this to go show administration, hey, I warned them 2 weeks in a row.
I heard it.
Okay? And like I said, this drawing, we're going to kind of consider it as your final project, basically, which is doing, because basically what this is not only sectioning, but it's kind of like multi-views too. So, if you are drawing a top view, and even though you're drawing sections, you're still having to draw kind of orthographic because you're having to catch anything in the background and all that kind of stuff. Any questions? All right, you will have a test this Friday on chapters 6 and 9. Actually, you know what? Let's scrap that. What we'll do is we'll have it. If y'all want, we'll do it Monday, since y'all will be here anyway for lecture. Y'all rather do that?
Take that first and later.
Yeah. Or y'all rather maybe it's going to be a Friday thing?
Well, that's what you told her.
Let's go ahead and do Friday. Yeah, because I think it's on D2. So Friday, we'll take test number, what's that, 3? I think it covers chapters 6 and 9. And of course, 9 we haven't went over yet. But it's not like I'm making you go out and answer the study guide yourself. You already have the answer. Alright? Well, we'll go over chapter 9 actually Monday. All we basically want to do is I'm going to show you the different systems of dimensioning. And I'm going to show you the different types of dimensions. And I'm going to give you a couple of, which you've already got some of them. And I'm going to give you a couple different measurements too that you got to go by. All right.
Take them out of the content or the quiz?
Content.